This chat session is for MGF 1107 students of Edison State College, soon to be Florida Southwestern State College. Chat session topics. Linear, functions, and their graphs. Textbook section 7.2. This chat session will be addressing 7.2, 7.3, and 7.4 in the textbook. A function whose graph is a straight line is called a linear function. All equations of the form ax plus by equals c, whose graph is a straight line, and a and b are not both 0, are called linear equations in two variables. The x-coordinate of the point where the graph intersects the x-axis is called the x-intercept. The y-coordinate of the point where the graph intersects the y-axis is called the y-intercept. To locate the x-intercept, set y equal to 0 and solve the equation for x. To locate the y-intercept, set x equal to 0 and solve the equation for y. Now we'll go on to the next screen and talk about slope. The steepness of a line is called the slope. The vertical change is called the rise, and the horizontal change is called the run. The horizontal number line, remember, is called the x-axis. The vertical number line is referred to as the y-axis. So if we have this line here, vertical change is called the rise, and the horizontal change is called the run. So this is our rise. And this is the run. The slope formula given 2 points, x1, y1, and x2, y2, is y2 minus y1 over x2 minus x1. Notice that the first number in the numerator, first number in the denominator, both come from the same point. The last number in the numerator and the last number in the denominator both come from the same point. Now, if we have a positive slope, the line will be rising left to right. If we have a negative slope, the line will be falling left to right. If we have a vertical line, it will turn out it will have an undefined slope because we'd be dividing by 0. And a horizontal line will have a 0 slope because we would end up with 0 in the numerator. Now we have different forms of linear equations. So forms of linear equations. First one we have is called slope-intercept. And that is y equals mx plus b, where m is the slope of the line and the b is the y coordinate of the y-intercept. This is probably the most commonly used form. Then we also have what we call point slope. And this is y minus y sub 1 equals m parentheses x minus x sub 1, where again, m is the slope of the line, and x1, y1 is a specific point on the line. Now, we have also vertical lines and horizontal lines. A vertical line, every point on the line will have the same x-coordinate. So if we have a vertical line, the equation will be x equals some number. And whatever that number is, every point on that line will have that same x-coordinate. But if we have a horizontal line, the equation of the line will be y equals some number, because every y-coordinate on that line will have the same y-coordinate. Now, we're going to go on to section 7.3. And chat session topics are systems of linear equations in two variables, linear inequalities in two variables. And this is textbook sections 7.3 and 7.4. Now, two equations in the form ax plus by equals c, where a and b are not both 0, is a system of linear equations. A solution to a system of linear equations is an ordered pair that satisfies both equations. For example, the point 1, 4 satisfies both equations 2x plus y equals 6 and 3x minus 2y equals -5. If we plugged in 1 for x and 4 for y, we would get a true statement for both equations. Now, there are different methods for solving a system of linear equations. Okay, first method we're going to talk about is solving a linear system by graphing. This is where you plot each line and look for the point of intersection. But keep in mind, if the lines are parallel, there is no solution because the two lines will never intersect. If the lines are the same line, then there is an infinite number of points of intersection. Another method for solving a linear system is by substitution. You solve either equation for one variable, then you substitute the expression found in step 1 into the other equation for that variable. Then you solve for the remaining variable. Now plug in this value for the newly found value into either equation to find the value for the remaining variable. The third method is solving a system of linear equations by the addition method. This is where you put both equations in the form ax plus by equals c, and then you multiply either one or both equations by a number so that either the x terms are exact opposites or the y terms. Are exact opposites. Add the two equations and solve for the variable. Then plug in this value for that variable into either equation and solve for the remaining variable. Exceptions. If you are using either the elimination method or the addition method and all variables disappear, then if you are left with a false statement like 4 equals 7, the two equations name two parallel lines. Then if you are left with a true statement like 5 equals 5, the two equations name the same line. Now, certain applications of linear system. We have what's called the revenue function, which is equal to price per unit times X, which is number of items sold. We have the cost function, which is fixed cost plus cost per unit produced times number of items produced. And break-even point is the point of intersection of these two functions, where revenue equals cost. Now, if we're talking about linear inequalities in two variables, first we solve for y and have y on the left hand side of the inequality. If the equal sign is there for the inequality, the boundary line will be solid. If the equal sign is missing for the inequality, the boundary line will be dotted. If the inequality symbol is less than, we shade below the boundary line. If the inequality symbol is greater than, we shade above the boundary line. The solution to the system of inequalities is where both regions are shaded. If you cannot decide which side of the boundary line to shade, select a test point in the supposed shaded region. If the point makes the inequality true, you have selected the correct side to shade of the boundary line. Otherwise, you have selected the incorrect side to shade.